Let's get started with writing our first Python class. So first of all, you need Python installed and you need to be able to write a little bit of Python to make use of this module and to make use of Python 301. So in front of me here, I just have VS Code. It's just a simple text editor. You can use PyCharm, you can use brackets, you can use any text editor you like. I just happen to like VS Code. So in front of me here, what I'm going to do is go to View and then go to Terminal and just open up that terminal. And that's just going to give me a terminal at the bottom and my file viewer on the left. Let's go ahead and create a new file here and let's call this firstclass.py. So let's take a look at writing our first class, but before we do that, we need to take a look at some of the syntax. So when we're writing a function, it's like something along the lines of def function name do a thing. A class is a little bit different. Now to instantiate a function, we simply say the function name, and that's it. Now a class is a little bit different. A class starts with the word class, and this is going to create what's known as an object. And in Python, everything is an object. A file is an object, a function is an object, a class is an object. But they're managed slightly differently. So a class starts with a keyword class, and then we typically give it uppercase naming, or at least capitalized words or capitalized letters. So we say something like class, this is an animal. And that's literally all there is to creating a class. And then to instantiate that class, or to use less fancier terminology, to activate this class, we say animal is equal to this is an animal. Now, at this point, this class is completely useless, but this will work. This won't give us any errors, and we can demonstrate that by going into our terminal and typing python firstclass.py. We don't see any errors. That means this is working the way we want it to work. If you don't see errors, that's a good thing. So let's go ahead and create a real-life example here. So this example is going to be literally just an animal example, and we're going to use this example through pretty much all of this Python 301 module, or this course. So let's go ahead and create a brand new class. We say class, we give it a name, colon, and then we can do something in here. Now in the next few lessons, we're going to talk about properties, methods, and things like that. But for now, let's go ahead and give this a simple property. And this is really just a fancy word for a variable inside of a class. And so we have something like a property, and this is actually keywords. We're not going to use that. We'll use like property1 is equal to something. Then we can instantiate this class or activate this class by saying the animal is equal to an animal class. It has the parentheses there, a lot like a function. And then we can say print the animal dot property1, and you can see it autofills for me using VS Code. And so this is a lot like a dictionary object, but a dictionary looks something like this. It's looking up a keyword. In a class, we use dot notation, and the dot simply means this is going to be some sort of class, and this is some sort of property or a variable inside of that class. Let's go ahead and run this. And we see that it says something, whatever this is in here. Now we can overwrite that, and we're going to talk about that in future lessons. We can completely change that. We don't have to use property1 at all. We could literally name this anything else. So I'm going to select this, go to view, or is it selection? Selection, add next occurrence, and that's going to select both of these so I can write in two places at once. And I can say, this is a property. And when I run this again, it's simply going to print out the word something. And so you can see that these two, even when I click it, they're highlighted at the same time. These are married. And so to make sense of this, we created a class called animal, gave it a property, just a boring, bland property. We hard-coded it, so it's actually not a lot of use right now. There's not a lot of use for it. Then we instantiated that class, and we threw it in a variable. And by doing that, we activated this class, or instantiated this class. Then we said, in that variable, activate the property. This is a property. Now right now this is a lot like a dictionary. The syntax is slightly different, but this is a lot like a dictionary. So what I would like you to do is create an example animal class, or really any sort of class, give it a property, hard code the value, activate that class, and then print out that property. So essentially do what I did in this video. When you're done that, let's head on over to the next lesson where we talk about class properties a little more in depth. Welcome back. In this lesson, we're going to be talking about class properties. So to carry on from our last lesson, I'm simply going to copy and paste what we have from our previous lesson, which I just renamed from the last video, just so it's a little easier to manage these files when you download the source. But I'm going to basically take this exact code and move it into this next lesson. And I'm going to do this moving forward through Python 3.01. So in the last lesson, we talked about this being a property. We have a class, this is a property, and this is hard-coded to be the string something. Now this doesn't have to be a string. This could be a Boolean, a list, a dictionary. It could be literally anything. But let's make use of something that's a little more complicated. So let's make use of a dictionary. So we're going to have a property in here. It's going to be set to some form of a dictionary. And in here, we could say key 1 is then equal to value 1. And then we have to instantiate that. We did this in the last lesson. We use the variable after the animal class has been instantiated. This is a property, and this is going to print out a dictionary. So if I run this, it prints out a dictionary. Now we know that this is a dictionary, and at this point, this is just a standard variable. There's nothing special about this. It just happens to be that there's a class here, then a property, consider it a variable. And then to access a key, like we would in a regular dictionary, we just give it the key name, and that matches right here. So when I save this and rerun the script, we can see it says value 1. And so we're going to see this a lot in professional level Python. We're going to see properties set as dictionaries. This is a very common thing. And so it's going to be really useful for you to know that this is a class, this is a property, and this property, its data type, or its structure, is a dictionary, which means we can then look things up. But it doesn't have to necessarily be a dictionary. We could say this list, and I'm just going to give it any name, is equal to a list of maybe names. So we've got Cain, Caleb, and Gully, who is a cute little cat. Actually, he's not little, he's a pretty big cat. And then we could say, print the animal, this list, and when we rerun this, we're going to see down here, it says Cain, Caleb, and Gully, and it shows up as a list. Now, because this is a list, we can do indexing and slicing and stuff on it, just like a regular list variable. It just happens to be it's inside of a class. That's really all there is to it. So if we wanted to get, let's say, Gully, remember lists start at 0. So this is 0 index, 1 index, 2 index. We'd say this list, hard brackets, 2. And this is going to print out the word Gully, or the name Gully for us, just like that. Now, when it comes to automatically assigning properties, we can do that with this thing called a dunder method, a double underscore method. We're going to talk about that in its own particular lesson. We can also use functions as properties, and that gets to be a little more advanced. We're going to talk about that in the next lesson. So in this lesson, what I would like you to do is create a class, give it 2 properties, and instead of just using a string or a number or some sort of simple data type, use a new type of data type, or not a new one, but a more complex data structure. So the first one should be a dictionary, and the second one should be a list, and then try to access that dictionary and list from within the class. Now, a fun thing we can do, because in other programming languages, we have these things called private properties. Python doesn't have private or public. It's all just sort of accessible. So what we could also do is print animal dot this list. And that's just simply going to, instead of throwing the class into a variable, we're going to access this property by its class directly. So if we go ahead and run this, we're going to see prints out our list for us, as we expect. So there is no private, there is no public, nothing like that. I know PHP and Java and all these other languages have that. Python doesn't have that. Oh, and one more thing, actually, I should not forget this. You're going to see this all the time. Whenever you see a property start with an underscore, like this is a private property. So this is how we get away with it in Python. Instead of saying this is going to be private, Like in some languages, we literally use the word private. We start with an underscore. And when we start with that underscore, we're simply saying this is a private property. Don't access it from outside of the class. So don't access it this way. It should only ever be used internally. Now, we don't know how to use those internally yet, so we're going to learn about that in the next couple of lessons. But what I would like you to do is go ahead and give this a shot. Try this out. Create an animal class, dictionary, list, private property, and then instantiate your class, print something out from your dictionary or list, and then try to print just straight from that animal class, one of the properties without instantiating it and without throwing it straight into a variable. So there's two ways to do this. Go ahead and give that a shot. Try it out. Please try it out. This is important because when you get into the world of, for example, machine learning or even just Django web framework, you're going to see classes everywhere. It's important to know how classes work in Python. Thankfully, they're pretty easy to learn. So in the next lesson, let's go ahead and talk about class methods. Hello, hello, hello. In this lesson, let's go ahead and talk about class methods. Class methods, honestly, it's just a fancy term for a function inside of a class. And so it looks exactly like a function. There's only one distinct difference here. So let's go ahead and get rid of this private variable. That's just from the last lesson. And let's create a new method. So this is a method. This is all there is. And this looks exactly like a standard function. And so all a method is a function inside of a class. Now, one thing to note here is that on a standard method inside of a class, its first parameter is always self. Now, if you come from like a JavaScript background, you're going to see this, or PHP uses this as well. PHP uses something like this. I think it's $ this and then an arrow. JavaScript uses the this keyword. In Python, we use the self keyword. And what that does is when we say self, we can now print self dot, and we have access to everything. And you can see VS Code has automatically filled this for me. We have self dot, this is a method, this is a property, this list. So let's go ahead and print this list. We've written a method here. Now let's go ahead and activate it. And to activate it or to run it, we're going to instantiate this animal class because this is a best practice. Instead of accessing animal on its own, we throw it into a variable. Then we say, the animal dot. This is a method, parentheses. And unlike a function where we see a keyword argument or a required positional argument in here, like self, we don't have to do that. We can simply ignore it. So even though self is used inside of the class, outside of the class, we completely 100% ignore it as if it doesn't exist. And that's just saying because this is a class object, inside of here, it's going to have access to everything inside of the class. And the reason we do that is so that we don't have to constantly put in new arguments. So we wouldn't have to say this list, this is a property, etc., etc., etc. We don't have to constantly pass these things in because we would have to put in a list here. And then this next one is going to be a dictionary. They're already set in here. We don't have to pass those in. So I'm going to undo that and simply run this as a method, print self this list. And again, self is referring to animal, this list, property, class, property. Let's go ahead and run this. Python 301, lesson 3, class methods, and it prints it out for us. So with the self keyword, we have access to other methods, other properties, all that other good stuff inside of this class. We don't have access to other classes yet. It's only this particular class, and that's what self is referring to. Self is referring to the animal class that we are working in. Next up, we can also define properties using methods. And again, to boil this down into more layman's terms, we can create a class variable based on a class function. So let's go ahead and create a function or a method called getGully. It's going to take self as its first parameter, always does, and we could return, because it's basically a function, self.thisList, And then gully is number 2. It's index 2. 0, 1, 2. Now, when we try to get this, we're going to have to say get gully with parentheses. Now, if this is supposed to act like a property instead of a function, let's say there's nothing in here and it's just supposed to return a simple piece of data, we can use this thing called a decorator, which we'll talk about in the future as well. And we just say at property. And what this is going to do is say any sort of logic in here, any logic. And this method could get huge. There could be 100 lines of code in here if we wanted to. It's always going to put this into a property. And when this is a property, we ditch the parentheses. Now, because we're using the return keyword, just like a function, this isn't actually going to do anything. This is a method up here is actually printing. In this case, let's make this a little more complex. Let's use a method like a regular function and actually return something. So then we could say gully is equal to the animal get gully, and that's going to allow us to use this later. So we could print the cutest gato of all time is gully. Let's go ahead and run this. And we're going to see that this prints two different things. It's going to print this is a method because it's executing this, which is going to print. And then we're going to print the cutest gato of all time is gully. And look at that, it prints our list just like it did in the first example. In the second example, in our second print statement, this is our class. This is our property. And you can see it actually looks a lot like a function, but it's got a decorator on it basically saying, hey, even though this is an executable object, or what we call a callable, treat it as if it's not a callable. Treat it as if it's a standard property like this list, and this is a property. And because we use the return keyword, it's going to be able to then throw that into a variable, any variable name, and then we can use that variable down the road. Now let's take a look at one more example. Let's create an example where we add a name to this list. So in here, we can say def, because we're going to create a method, add name. It's always going to take self, and then name is going to be the parameter that we're going to add. Then we can write self.thisList.append that name. And we can, if we wanted to, return either self.thisList as the entire new list, because all we did was take a list. If you forget about the self for just a second, it looks just like a regular list, list.append. This just happens to be accessing it from outside of the function or the method. So we have class, property. It's a list, so we can use .append on it. We're going to append the name here. And then it's going to return this list for us. And we're going to see this a lot. So let's go ahead and comment out that code. And let's say the animal dot. And what did we call it? We called it add name, and it takes a name. Ignore self. Self always goes in there, but we ignore it. Add name, and then the name is going to be rhubarb. Then if we wanted to, we could print the animal dot this list, and we're going to see that this list now has Cain, Caleb, Gully, and rhubarb. So we're dynamically adding things to our properties now using a method. Let's go ahead and run this. And it says Cain, Caleb, Gully, and rhubarb just as expected. And again, all we're doing here is we're using data types, standard Python data types inside of a class. And so we're encapsulating, or, to boil that down because we like our big words as developers, instead of encapsulate, think of it as contain. So all we're doing is containing all of this code in a class. And the idea here is that we're grouping functions and variables or methods and properties. We're grouping them together in this thing called an animal, this class called an animal. And the idea here is that all of these are related somehow. So what I would like you to do as your task for this lesson is create a class animal, create a property, make it an array or make it a list, a Python list. Then write a method to not add something, but to delete something from that list. So instead of @name, it could be called remove name. Remember, it takes self as its first parameter. 100% of the time, it always takes self. Inside of this particular method, we can then access self dot whatever your list is called dot remove, and then the name. And then down here, we can say, well, we instantiated it. This is our class. This is our method name. So yours would be called remove name, and then the name to remove. And then you can print out that entire list again and see that it was actually, in fact, removed. In the next lesson, let's go ahead and clean this up so this looks a little more like a real world example, because right now this is messy code and this is just tutorial code. This is no good. Let's create a real example of an animal class in the next lesson. All right, taking off from that last lesson, what we're going to do is clean this up a little bit and create somewhat of a real animal instance, or sometimes we call a class an instance because it is an instance of a class. But we're going to basically get rid of all of this, and we're going to create a proper animal class. So what kind of things does an animal have? An animal has a fur color, and let's say that fur color is going to be orange. Then an animal also has actions it can take. What kind of action can it take? It could def eat. It could do something. And remember, we always put self in here. We could also do def chase because it's going to chase down its food. Let's say this is like a tiger or a cheetah or something. And this is also going to take self as its first parameter. Then we instantiate this class. Let's call this tiger is equal to an animal. And then we can make that tiger, we can make it eat, we could make it chase, we could print out its fur color, or we can make it, let's do this, def speak. It's going to take self, and this is simply going to print rar, rar, animal dot speak. And so when we run this, when we run Python, lesson 4, class cleanup, it's going to print out rar, just as we expected. Now this is nothing that we haven't covered already. And if you're just stepping into Python 301 and you're sort of new to Python and you're just wondering what this pass is, this simply means don't do anything but allow indentation. Because if we don't have this pass in here, let's go ahead and see what kind of indentation error we're going to get. We get an indentation error. Expect an indented block after def chase. Actually, it's looking for it in here, doing its best to figure out where it is, but we simply put pass in there. Now, this is a very generic class, and there's honestly nothing super useful about this. But in the next lesson, we'll talk about class inheritance. So there's no task for this lesson. I just wanted to show you that I'm going to clean this up a little bit. In the next lesson, we're going to extend this animal class, and we're going to create, let's say, an actual tiger or a different type of animal. And then we can overwrite the speak method, the eat method, chase method. We could add all sorts of things to it. So when you're done watching me clean up this code, let's head on over to the next lesson where we talk about class inheritance. Class inheritance. So one of the really nice things behind Python, or I guess really any class in any language, it doesn't have to be Python, but the nice thing about a class is that we can extend it. And so instead of just saying class animal and then have another class called tiger and another class called house cat, we could, instead of having to write speak, eat, chase, fur color over and over and over again, we can simply extend it. And so what I'm going to do here is get rid of this and create a new class. And this one's going to be called tiger. And in brackets, it's going to extend animal. And I can type pass in here to literally do nothing. And it's automatically, because it's extending this animal class up here, it's automatically going to get the fur color, speak method, eat method, and chase method. So what I can do is now write tiger is equal to a tiger class, tiger.speak, and instead of writing animal is equal to an animal class or tiger is equal to an animal class, we can now say tiger is equal to a tiger class and then the tiger speak. So let's run this code and let's see what happens here. We're on lesson 5 and it says rar. Now just for fun, let's go ahead and print this out. Let's see what kind of type this is. Print type tiger. And it's going to say rar, but it's also going to say main tiger. This is different from animal. If we swap this out for animal, we're going to see that, well, it still says rar, but the class main animal. And so we swap that out. Now, what's nice about this is we can overwrite everything in here. So instead of saying speak rar, we could say something else. Def speak, it takes self. And what is this tiger going to say? They're great. Like Tony the tiger. Get it? Okay. Maybe not the greatest joke I've ever made. But let's go ahead and run this. And we're going to see that, actually, let's get rid of this line. We don't need that anymore. When we run this, it's no longer going to say rar. Because we're instantiating the tiger class, it has speak. Its inheriting class, it also has speak. Which one is this going to run? Well, because we're instantiating the tiger class and we're overwriting speak, it's going to run this one. So it's going to say, they're great, as expected. Let's go ahead and create one more example in here. Let's create a house cat class. House cat. It's also going to extend from an animal. And when we overwrite speak, we're going to make it say, meow. And that's all we're going to do there. And instead of tiger, tiger speak, we can still keep that instantiated if we wanted to. It's not doing anything, so we could actually delete it. But let's show you an example where we have both a tiger class and a house cat class. So we could now write cat is equal to house cat, cat.speak, and let's also write tiger.speak. And one's going to say they're great, and the other one's going to say meow. And let's go ahead and run this. And it says they're great, and meow. Now at this point in time, you're probably thinking, well, this is no good. I mean, I might as well write a regular house cat class and not extend from animal if I'm overwriting the one thing I'm using anyways. If that's what you're thinking, yes, you're absolutely right. Let's go ahead and look at that fur color though. Let's print cat.fur color. And we're going to see that this is orange. They're great, meow, and it says orange. But we can overwrite that. We can say the fur color is equal to black. Let's save that and rerun this, and it's now going to say black. And so by default, it inherited orange as its fur color, just as a default, so it's kind of like a blueprint. And then we change that fur color for this particular house cat to be black. Now essentially what we're doing here is we're creating some sort of blueprint with this class, and this is called an interface. In the next lesson, we're going to talk about interfaces and sort of what they are and how we implement them and the reason we even write them. But for now, what I would like you to do is create a class called animal. You might already have one. And then I want you to extend that class. I want you to inherit that class by writing class, your new class name, extend animal by putting animal in brackets here, in parentheses, and then you can overwrite its attributes or its properties. You can also overwrite its methods. And then I want you to instantiate that house cat or whatever animal you choose to use. And then whatever method you chose to overwrite, whether it's speak, eat, maybe something brand new, maybe it's something that's outside of what you've seen in this module so far, I want you to execute it. Cat.speak is going to print meow. And then I want you to, as you have overwritten one of your properties in here, I want you to also print out that property. And so here I just did print cat.furColor. And again, it's really, really important that you learn how classes work, because in frameworks such as Django Web Framework, we're going to be using a lot of classes. And it's important to know that even if you didn't know what animal had, let's zip that up there, just collapse that. So even let's say you don't know what's inside of animal, you would be able to somehow overwrite what is inside of animal. You would be able to explore and figure out, oh, an animal has a fur color, but I want to overwrite that. It has a speak method. Oh, okay, yeah, it's got a default speak method, but I want to overwrite that too. So when you're done that, let's head on over to the next lesson where we talk about class interfaces. Let's have a conversation around what an interface is. So essentially, if you wanted to boil it down, a class interface is literally just a blueprint. And so all it's saying is there's going to be some sort of property, there are going to be some sort of methods, or just a method, and it's simply supposed to implement something. And in the last lesson, we created a tiger and a house cat. Let's go ahead and just delete these just for a second. We'll create new ones. Let's work with just this animal. And typically when you see an interface, you're going to see that there's some sort of method and it's just going to pass. Or you're going to see something like raise not implemented error. And let's give this a better example here. Let's extend animal. Let's do class houseCat is going to extend the animal class and simply pass. Let's then instantiate that houseCat. So we could say houseCat is equal to houseCat, or cat is equal to houseCat. And then we could do cat dot. And which one did we overwrite here? Well, we didn't overwrite anything, but we know that it's going to automatically inherit speak from the animal class. So let's go ahead and speak. And let's run this file. This is lesson 6 class interfaces, and it says not implemented. Now the idea here is that you simply have a blueprint, and that when you use this, you're supposed to implement this. If you want to use it, you have to implement it. And so to get rid of this not implemented error, or if it's just pass and it's returning none, we could simply say def speak. It's going to take self as its one and only parameter, mandatory parameter inside of a class. Print meow. And so what this is doing here is it's saying, hey, houseCat is going to use the animal interface, or this blueprint. If we try to use speak, well, there's nothing implemented, so we have to implement that. And because we extended animal, we overwrote speak so that this no longer works. So you can kind of think of it like this. We take these two lines, and it's a lot like this. Boom, we simply replaced it. But the interface, or the blueprint, is simply meant to tell us that it's supposed to be implemented. So when we save this and rerun this, we're not going to get a not implemented error. We are now going to get print meow as expected. And so that's pretty much the only role of an interface. An interface is a blueprint that says, hey, if you want to use the speak method or any method, you have to implement it yourself. But just so you know, whenever you extend from it, houseCat will always have the speak method. And it's our job as developers to overwrite it. Now, your task for this lesson is to create an interface. So if you already have an animal class, if you've been following along with Python 301, you probably have an animal class already. Go ahead and instead of using speak, go ahead and raise a not implemented error on eat or chase, or another function or method of your choice. Extend that class or inherit that class, create a new one. I just created one called houseCat, and then overwrite that method. You might have already done this once before. It's not a bad idea to do it again. This time we're implementing an interface with not implemented error. Next up, we're going to talk about the super function. So a lot of the time you're going to see with classes that because we can extend a class, you're going to be able to access a function above it. So think of this as below and animal is above. And so if we think of this as a hierarchy, which is how I like to think about it, we are simply overriding speak, which is what we did in the last lesson. But if we wanted to, we could execute whatever is in here. So instead of overriding speak, let's overwrite eat. So in our animal interface, let's go ahead and print I am eating yum, yum, yum. And because we're extending houseCat from animal, we can now instantiate that houseCat and we can say eat. And we've done this a few times already, so we're not going to see anything new in here. It says, I am eating yum, yum, yum. And even though houseCat doesn't have a eat method on it, the class it's inheriting from, animal, it has it. So we're allowed to use that. Now, let's say we wanted to overwrite the eat method, but we also wanted to execute the code that's in here. Let's do two examples here. Def eat self print I am eating salmon. And when we re-execute this, cat.eat, well, we've overwritten the original eat interface method. And so all we're going to see now is I am eating salmon. But what if for some reason we wanted to also execute this? What we could do is we could sort of bubble it up. So remember, this is the bottom, this is the top. we could bubble up to the animal class and execute eat. Now there's two ways to do this. There's the right way and the wrong way. The wrong way is to write animal.eat. Because this isn't instantiated in a variable yet, or anything proper. I mean, we can access it technically, but really, we shouldn't do it this way. And then the right way is to simply say super, it's a function, dot, eat, and if there are any sort of extra parameters in here, we just simply match the parameters. We don't have any parameters, we don't have to pass in self. It's in a class, it already knows that self is being passed in automatically. And so what this is going to say is, get the class that's above it, the animal class, that's what super is doing here, and then execute the eat method. So it's going to get that animal class, then that eat method. And then it's going to execute it for us, because we said eat with parentheses right there, execute it. And so it's going to print I'm eating yum yum yum, and then it's going to print I'm eating salmon. Let's go ahead and save this and give this a try, and we're going to see it does exactly what I'm describing here. I'm eating yum yum yum, I'm eating salmon. And so all this did, again, was bubble up to that animal class, execute.eat, whatever is in here, could be a print statement, could be anything. It will execute everything in there. And then we wrote whatever else we wanted. And again, this could be any logic that you want to write whatsoever. It doesn't really matter that it's a print statement. It could be mathematics. It could be a web scraper. It could be anything you want. Now let's go ahead and do one more example with chase, but let's add some keywords in here. So in our animal class, we have def chase self. And what are we going to chase? We're going to chase a gazelle. That's what we want to chase. So let's chase an animal. And this is going to print, I am chasing an animal. And let's make sure that animal by default is a gazelle. I hope I'm spelling that right. Maybe not. And when I go down here, cat.chase is now going to, because we haven't implemented it yet on our own, it's coming from the interface, it's going to say I'm chasing whatever the animal is, which happens to be a gazelle by default. Let's go ahead and run this, and it says I'm chasing a gazelle. Now we can also pass in a keyword in here. The cat might be chasing a mouse. Let's go ahead and run this, and it says I am chasing mouse. Funny English there. I'm chasing a gazelle or a mouse or something like that. Now to implement chase, we can we can write def chase self animal. It's going to match what we see up here. The animal by default is going to be a gazelle, but we're always going to pass in an animal, so we're not going to make this a keyword argument. We're then going to say super dot chase. We're going to pass in that animal up here, whatever that's going to be. So it's going to say I'm chasing by default a gazelle, but maybe the animal is chasing a mouse. I'm chasing a mouse. And then we could print animal was caught. And we could use f strings if we wanted to, or just a regular print statement. It doesn't really matter at this point. These are just examples. Let's go ahead and run this. And this is going to run cat.chase, which is here. It's going to super up to this one. It's going to say I am chasing a, whatever the animal is. By default, it's a gazelle if it's not provided. And here we're saying it is required. And then we're going to pass that in. Let's go ahead and run this. And it is missing a keyword in here. So let's go ahead and throw mouse as a keyword in here. And not a keyword, but a required positional argument. Let's go ahead and run this one more time. And it says I'm chasing a mouse. Mouse was caught. And so chase is now doing whatever the interface is telling us it's going to do. We then bubbled up using the super method, or the super function. We said, hey, wherever this is extending from, whatever class it's extending from, use that. Then run the chase method, and we simply passed in animal. So animal is actually doing a lot of traversing here. We passed in animal as a string here. It's going to then go into here, then going to go into here. It's then going to be overwritten here. So instead of gazelle, it's going to be mouse, and we're simply going to print it. So we're moving data around quite a bit. And this is very common in Python. It's actually common in all class-based languages. So that all happens before it even gets to print animal was caught. And then it prints animal was caught. Now, this is somewhat of a tricky concept to wrap your head around. So what I would like you to do is create a brand new interface class. You can call it animal, just I would like you to write it from scratch, just as good practice, you know? So create like an animal interface, make it chase something, and it simply does a thing. Then extend that animal. I extended mine to be a house cat. Yours could be a tiger, a cheetah, an elephant. It doesn't really matter. Just make sure you extend it. Overwrite that chase method and use this super function in it. And remember, super is simply going to say, oh, okay, this is extending from a class, animal. That's our interface. That's up here. And then it's going to say chase. So it's now talking about this animal. That's super. Chase. That's this method here. It's going to then print, I'm chasing an animal of some kind. And then execute some code underneath it. We're just using simple print statements, but you could actually use proper Python logic if you wanted to. You could add numbers, you could scrape a website, you could do pretty much anything. We're just sticking with something fairly simple to get our heads wrapped around the idea of object-oriented programming. Once you've done that, let's move on to the next lesson where we talk about dunder methods. And a dunder method essentially lets us take automatic action. And for instance, our animal always has a fur color of orange, but what if we're using an elephant? Well, then we would have to write the fur color in here. I guess is going to be gray. Or we're going to have to take that house cat and we're going to say cat.fur color is equal to gray. And at this point, we're just working with variables. That's no way to live your life. We might as well throw it into here when it's being instantiated. We'll talk about that in the next lesson. Let's talk about dunder methods. And so what I'm saying here is D-U-N-D-E-R, dunder. And what this means is double underscore. And so these are magic methods that come with the class. If you're already familiar with classes in another language, you're going to be familiar, for the most part, with dunder methods, or magic methods as they're called in some other programming languages. So let's move back up to our animal here, and let's create a dunder method called init. And it starts with def underscore underscore init underscore underscore. It's a method, so it always takes self as its first parameter. And then we could give it any other parameter. And so this could be fur color, and then it can do a thing. And what this allows us to do is in our code down here, which we're extending, we can now put a fur color in here, and that fur color could be gray, for instance. Now, currently this is not going to do anything, but if we execute this code, we're going to see that there is not going to be an error. There's just no error that's going to show up. It's going to be nice. Cool. It's doing exactly what we did in the last lesson. But what we're saying now is we can pass in a positional required argument. Let's go ahead and run this without gray in there, even though init is accepting fur color. And we see missing one required positional argument. Now, let's back this up a second. What is init doing here? Init is simply saying when you instantiate this class, when you activate this class, even if it's being extended or inherited in another class, we now need to pass something in. This is going to be run before any other function. And so whenever we use underscore underscore init, what this is saying is throw in some sort of parameter or parameters or arguments, and that's going to automatically execute, so we don't have to then type cat underscore underscore init gray, something like that. It's just going to automatically do it for us. And so we can type gray in here. And let's go ahead and let's demo that this is going to execute before all of our other functions. Print fur color is fur underscore color, and let's use an F string here. And it says fur color is gray, then it executed I'm chasing a mouse, then it executed mouse was caught. And so there's an order of operations here. Now init is by far the most common one you're going to see. And this just simply means that we can work with fur color. Now by default, that fur color is going to be orange. Let's go ahead and get rid of that. We don't need that anymore. And we can simply, because we know that this is going to be executed first, we can simply say self.furColor is equal to fur color. And what this allows us to do is then use self.furColor in any other method that we want to use, whether it's in the animal class or it's in an inherited class or an extended class. It's going to automatically assign that for us. So let's get rid of that print statement and let's create another method in here. Def get for color self, and let's simply print self.furColor. Now, for the most part, you can ignore all of these because we're not going to be using them in this video. What we're going to do is create a class, automatically throw in the fur color. It's going to then assign self.furColor. We can then, once we instantiate this class, we can do cat dot get fur color. This is a method, so it takes parentheses. And what that's going to do is, because there's no get fur color method in our house cat, but there is one on the animal interface, it's going to execute this. And it's simply going to execute whatever color we put in here. And just as a better example, let's write this out. Getting fur color. And this is going to say getting fur color gray. It says getting fur color gray. Let's do orange. 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 And it's going to say getting fur color orange. And so what's nice about this is now we can use the super function. So we can say def init on our extended class self fur color super init, and that's going to take the fur color as well. And so anytime we instantiate a house cat, like we're doing down here, we're going to overwrite that init function, this one up here. But instead of just overwriting it, we actually want it to do everything it's doing by default. Let's say we're happy with that logic. We don't want to overwrite it. We simply want to extend from it. So we're going to allow self.furColor to be assigned, and then we can, if we wanted to, print something like fur color was saved to the class object. And then we could do something else in here if we wanted to. But you're going to see this a lot too. In professional level Python, you're always going to see an init, or not always, but a lot of the times you're going to see init, and sometimes you're going to see us overwrite it. And so we're overwriting it here, and we're saying, actually, we do want to overwrite it, but we also want to use the regular logic that comes with it, whatever that may be. And then we want to maybe do something else. So let's say we didn't necessarily want to overwrite the animal type every time. We could say, up here, animal type is equal to unknown. And we could force that animal type in the house cat. Self.animalType is equal to house cat. Let's go ahead and print self.animalType. And so at this point, we're now using init, we're using a dunder, we're using super, regular print statement, we've seen that a trillion times already. We're then forcing that animal type to not be passed into init. It's not in there whatsoever. By default, it's unknown. But because it's a house cat, we want to hard code this. We want to say, house cat is always going to be a house cat. No matter what we do, it will always be a house cat. It is not changeable. And so we do not throw house cat in here. We're simply saying instantiate house cat, and it's going to have an animal type of house cat in there. And it's going to print that out. Let's go ahead and run this. And it says fur color was saved to the class object. That's right up here. It ran super up there, so we we know that self.furColor is accessible. We have access to that in all of our methods. Then we said the animal type is a house cat and print that animal type. And so first print statement, house cat is the second print statement. Where is it? Right there. It says house cat, and that matches down here, word for word, letter for letter. And then we're getting the fur color, and we're saying it's orange. And that's coming from here, get fur color. And we simply set that fur color in init. This is getting to be pretty advanced Python, to be honest. But we're passing it in here, saying self.furColor, and then in a method, we're accessing self.furColor. Now, if you're looking at this video, scratching your head going, whew, I don't understand a single thing that was just said. What I would like you to do is try this out. I want you to try this out until it makes sense, because you're going to see this everywhere, especially in professional level Python. This is very important that we understand both super and dunder methods. Now, in this lesson, we're really just talking about the dunder method. And the dunder method in init, as a recap, simply means execute this before every other method inside of our class. We can overwrite it. We can use super on it. We can do anything we want. It's a lot like a regular method, like speak. It just happens to run first automatically, and those parameters get thrown right into the class instantiation. And so now this looks a lot like a function with a parameter. The only difference is this is a class, and this is automatically going to be accessible throughout the rest of our class. I want you to give this a try. Please spend at least 10 minutes on this and just tinker around with it. Even if you can't get it to work, it's good to spend that 10 minutes on it. And just because how brains are designed, even if you struggle with it, it's okay. It's good practice regardless. Go ahead and give that a shot for about 10 minutes. If you don't get this working in about 10 minutes, feel free to move on. You'll have lots of time in the future to practice using dunder methods and super. Welcome back. Let's stop talking about classes. Okay, we spent something like 8 lessons together talking about classes, and yes, they are important in Python. They're extremely important in Python, but there's another thing that's extremely important in more advanced Python, and that is how we can manage error flow. So we do this thing, try a thing, except another thing. And what this is simply doing is say, try a block of code, and if there's an error, do something else. So it's a lot like an if-else statement. The only difference is it's looking for errors. And so let's take a look at a simple try except. And so the syntax looks like this. We're going to try a piece of code. And so let's try total is equal to 1 divided by 0. Now, if we go into our Python shell and we do 1 divided by 0, we're going to see this gives us a 0 division error. You cannot divide by 0. Mathematically, it's just one of those rules. We're not allowed to do it. So what we can do now is accept any sort of exception, and we can say that total is going to be 0. Print the total. And this is really all there is to a try and except block in Python. The important thing here is that it's going to try a piece of code. If it fails, if it raises some sort of exception, like what we see here, a 0 division error, it's then going to skip this line of code and everything below it. This will not execute. Simple as that. It's then going to pop out of this block and it's then going to then try to execute the exception. And so when we run this, Python lesson 9, errors and exceptions. I didn't spell exceptions right, by the way. I have to fix that. That's going to bug me. Exceptions. Better. We see the total down here is 0, and that's because it's getting 0 here. And as an example, let's do this. Print trying 1 divided by 0. Let's move that up to the top. And then let's print something underneath. This will not show up. And let's print one more in here. Exception was caught. Let's go ahead and run this one more time. And it says trying 1 divided by 0. This will not show up, did not show up in our script down here, and it says exception was caught. Now, at this point in time, you should be thinking, oh, geez, where am I ever going to use this? I hope you're asking that question. And if you are asking that question, let's move on to a proper example here. What happens if we ask the user for some input? So ask for a number. We're going to say input, what is a number? Then we're going to make sure that this is always a number. So we're going to say num is equal to, and we're going to cast it as an integer. So no matter what someone types in here, it's always going to be a number. It's going to be a full number. And let's print that. Print num. And when we execute this, what is a number? Let's write 10. And it just says 10. Cool. But what happens if someone doesn't write a number? Well, that's still going to get stored in this variable. We're then going to try to cast that number as an integer. And what if it's not an integer? What if we write Python 301? we get a value error. Invalid literal for int with base 10. Basically what that's saying is it cannot turn a string into a number with the base of 10. But the TLDR, the short story here, is it simply failed. We could not print this out. We couldn't work with this. So what do? We ask for a number. We try to cast that as an integer. If it doesn't work, we can do except all exceptions. We can then say that number is going to be unknown and simply print it. And this is going to allow us to print that number, which it didn't do before because it errored out, and it's going to say unknown. So let's give this a try. What is the number? Python 301. And it says unknown. If we execute this again, give it an actual number, it says the number is 10. And so what this did was it said, oh, actually, we can't manage this value error. Python just doesn't know how to turn a string into a number properly in a way that's predictable for you, the programmer. And so then it throws an exception. We catch that exception and we overwrite num to be unknown. And then we just printed it out. Now this is a really good use case because what if you're trying to do something and it doesn't turn out the way you expect? Now what I would like you to do is try this out. You can either try out the first example, this one up here where we tried to divide 1 by 0, simply doesn't work. Or you can try out this example, which is the one I prefer because it's closer to being a real life example. Ask for some input. Try to cast that number as an integer. Catch the exception, overwrite the number, and then print it out. And the nice thing about this is we are getting into simple error handling and error flow. And again, what's important about this is in our first example, if we look here, our code simply died. There was no way to recover from that. And so all we're doing with a try except is gracefully catching that error and managing it so our script doesn't die, so that our code can continue executing the way it's supposed to execute. Go ahead and give that a try. It's a pretty straightforward example, so this should only take you a couple of minutes. When you are ready, move on to that next lesson where we talk about catching some new exceptions. We're going to catch particular exceptions. Let's talk about catching particular exceptions and figuring out which exception is throwing and how we can manage multiple exceptions. So let's create an example here, and this is just going to be recreated from the last example. We're going to say some sort of number is equal to input, enter a number. Then we can try to change that number into a number, because when we ask for input, it always comes back as a string. And we can accept that exception by doing anything we want. And let's just say this number is going to be unknown. And let's simply print the number when we're done with it. Let's go ahead and run this script. This is lesson 10. Enter a number, 10, prints 10. Enter a number, Python. It says the number is unknown. In the first example, we entered a number 10. It came back as a string, and int was able to typecast this to an integer. So that worked perfectly fine. In the second example, we typed Python. Essentially, this is what we did. Now, we can't turn a word into an integer. It just doesn't work. Python doesn't know what Python, the string, is supposed to turn into as a number. Not in a predictable way anyways, so it throws an exception. Now, when that exception is thrown, we said that number is going to be unknown. Now, how do we know what that exception is? We can figure out what this exception is by typing except exception as e, print exception was caught. And then we can print type of e. Let's go ahead and run this again. Let's type Python as our number, and it says exception was caught, class value error, and it's unknown. So now what we can do is we can accept specifically a value error. So we can add another exception in here, except a value error, print num was not a valid number. And let's try this out. This has multiple exceptions in here. So let's type Python as a number, and it says Python was not a valid number. and then it printed it down here. Python is what we wrote. Could not cast it to a number or an integer. Then we said whatever that value was is not a valid number. Now this is a lot like an if, elif, else statement. So it's going to try something like an if statement. If it then catches this particular error, it's not going to run any other exception in here. It's only going to run this one particular exception. And so now we have a way to deal with a specific value error. What if we wanted to then do something with this number? Let's say num was perfectly acceptable. It was the number 10, and then we wanted to divide it by another number. So let's create a second input. We'll call it num2. Enter a second number, and we're going to divide these. Then we're going to say num2 is equal to int num2, and the total is going to be num divided by num2. Now, if num1 and num2 are both able to be cast into an integer, total is going to run. However, if one of these cannot be cast into an integer, it's going to then throw a value error. We're going to then catch that value error with an exception and print whatever number was not a valid number. And in fact, it might not be num, it might be num2. So let's say num or num2 were not valid numbers. And let's try this out. Enter a number. Let's do 100. Enter a second number, 10. Okay, no errors, that's good news. What if we did the first number to be 100 and the second number is 0? Well, in the last lesson, we tried to divide by 0. We can't do that. And so we can see that the exception was caught. It didn't execute a value error because no value error was thrown at us. So we can't catch that error. But there was another error or another exception that was thrown at us that we can then accept. Then it prints exception was caught, print the type of the exception, and we worked with the number, which we actually don't need to do anymore. We might want to work with totals instead. I don't know. Now, when it prints type E, it says class 0 division error. What we can do is catch that on its own as well. We can say except 0 division error, print. Numbers could not be divided. Divided. And let's get rid of that. Let's try this again. Enter a number, 10. Enter a second number, 0. And it says numbers could not be divided. There was no value error thrown this time. That means both of these were able, both these numbers, num1 and num2, were both cast into integers perfectly fine. So there was no value error to catch, so it skipped over this. But then it said, total is equal to num1 divided by num2, 10 divided by 0. Well, you can't divide anything by 0. We get a 0 division error. So we said, okay, try to catch a value error if it exists. If it doesn't, let's try to catch the 0 division error. We then caught that 0 division error and printed something else out. And because this one was executed, the generic exception at the bottom was not executed. This code was simply skipped. So Python is going to pick one of these exceptions, whichever one is the right one, and it's going to execute one of these avenues of code. It will always, always, always try to execute this code. And if there's any errors, it's going to check to see if it was a value error, check to see if it was a 0 division error, check to see if it was a general, broad exception of some kind that we aren't explicitly catching. And so at this point in time, we are now catching a value error, 0 division error, or if there's some kind of other error that's unknown to us, we can then work with that. Now, I say try and catch because I come from other programming languages as well. In Python, we say try except. It's the exact same thing, just a different keyword. And you're going to see try except all over the place in professional Python. And the reason for that, again, is because we want to try something. And if there's an error, if we don't try and accept that error, our code is simply going to die. We don't want that to happen. We want it to keep executing. We want it to keep on keeping on. And so we gracefully catch each one of these errors, or we broadly catch every error, every exception, and work with it. And that just means that our code can keep working. It's not going to error out on us. And that means all of our code down here will still execute. And that's good news. Because what if you're building a program like Google's web scraping bot, and it gets to a website and it's trying to scrape a particular email address and verify an email address. And maybe that email address doesn't actually exist. Like it passed, we thought it was an email address, but it's not a real email address. Well, if Googlebot didn't catch that error, it would simply die, and then someone would have to go and restart it. And you'd have someone at Google all the time just typing Python scrape internet, Python scrape internet, Python scrape internet, Python scrape internet. And our job as programmers is to, if we can, automate ourselves out of a job. And so it's going to then maybe try to get an email address or another website. It's going to then try to do something, and if it can't, maybe it skips it. Maybe it tries a different chunk of code. Maybe it tries to do something else. And then we don't have someone at the other end of a computer typing Python scrape internet.py, Python scrape internet.py, Python scrape internet.py every time it errors out. It's just automatically going to handle it for them. And that's the power behind try and accept, is you can accept any sort of error. These ones just happen to be keyword errors thrown exactly from Python. We can create our own as well if we wanted to. And then we can gracefully handle an error. And that means our code will run forever without any problems. Now, what I want you to do, I want you to try this out. Write some sort of example, and you can steal my example if you like, where you try some code, and you accept one error, one specific error type, then you accept another error type, and then you accept just a general error as E, and make sure you print out type E so that you can, deal with that later. Go ahead and write this complex try accept block, and when you are ready, let's head on over to that next lesson. Good luck, and I'll see you over there. Let's talk about decorators. Now, if we go back to a particular lesson, it's one of these, methods? Yes. We can have this thing called a decorator. And a decorator is simply a function that wraps around another function. And in this lesson, we're going to create our own Python decorator. So let's get out of this and create a new Python file. We'll call it lesson 11, decorators, decorator. So typically we have some sort of function, myfunc. And this is simply going to print, my name is Caleb. Then we can run myfunc like this. This is Python 101 stuff right here. Cool. This works. Very bland, very boring. This isn't in a class. This isn't in a try catch. This isn't doing anything new. But let's say we wanted to write a decorator, which typically looks like this. Decorator has the @ symbol and then the name of a function. And all that's going to do is execute a function called decorator and throw this function inside of it, so that we can execute something before or after automatically. So let's go ahead and create a decorator. And so we can create my decorator, and this is going to take a function, just like myfunc. Myfunc is going to be thrown in there as an entire function, not as a variable, but as a function. So we're passing functions into functions at this point. Then we can create some sort of wrapper. We typically see the word wrapper. This is very, very common. Print, do something here. Then we can execute that function, whatever that is. Print, original function is finished. And let's simply return the wrapper. And so this is a function inside of a function. We actually saw this, I think it was in Python 201, where we could put a function inside of a function. And this was essentially a decorator at that point in time. And so what we're saying here is my decorator is going to take a function as its only parameter. It's then going to register a new function called wrapper. It's going to do a thing, execute that original function. We're talking about weird scoping at this point. In JavaScript, this is called a closure. Execute said function, whatever that function is, and then print another statement. Lastly, we return the wrapper. So now there's two ways to decorate a function. Let's go ahead and get rid of this up here because we know that myfunc is simply going to print my name is Caleb. We could call this new function is equal to my decorator. And because it takes a function, we're going to throw in myfunc. Now notice we don't have the parentheses here. We're not executing my func. We're simply throwing it in as a function by itself, not as an executed function, just as the function object. Then we can say new func, execute this as its own function. Let's go ahead and try this out. And it says, do something here. My name is Caleb. Original function is finished. And really, this is all there is to a decorator. Now, let's go ahead and do this in a more Pythonic way, a more modern way. Let's cut that. Let's move it up top. And let's decorate my func with my decorator. And because we're using this sort of syntax, we don't need to wrap this in here anymore. We can simply write my func. Let's go ahead and get rid of that. And let's type my func. My func, my function here, is decorated with my decorator. It's going to pass in this automatically. It's going to register wrapper, print a thing, do a thing, print the original function is finished, return that wrapper. Let's go ahead and save and let's run this. And it works the same way. Now this is very Pythonic. I like this way better. You're going to see this way probably more often than not. And all this is the exact same as that first function, or not the function, but the first example. And all we're saying is, hey, use the @ symbol here as a decorator, wrap my decorator around my function. So it's going to execute my decorator, and somewhere inside of there, it's going to execute the original function. And then we can do something before or after, or nothing if we don't want. We could literally do nothing. I mean, that would be pointless of a decorator to do nothing. But we could do something before and after, which makes us really, really powerful. Now, why would we ever do this? Well, because sometimes we have a function and we simply like what it's doing. And we just simply want to add a little extra logic to it, a little extra functionality. And so we don't necessarily always want to change our original function, but maybe we do want to take that original function and extend it. So it's a lot like class inheritance, where we took a regular class and then we inherited it into a new class, or extended it into a new class. This is taking a function and extending it with my decorator. Now this is a very, very, very simple decorator, but it gets the example across. So what I would like you to do is I want you to create a decorator, and I want you to use it this way. Don't use it the function-based way, the original way, which you are going to see from time to time, but this is the more Pythonic way. So create a function, call it my decorator. Its only argument is going to be the function itself, not the executable function, just the name of the function. And so basically we've reassigned a function name as a variable in here. Inside of that, you're going to need to register another function, do a thing, execute that original function, do a second thing, and return that internal function. So we have functions inside of functions. You want to return that internal function. Then create another function, just a regular one. It could be a print statement. It could have some actual logic. It could do anything you want, and decorate it with @myDecorator. Means it's a decorator. My decorator simply matches the name of the decorator function. Go ahead and execute my func with and without the decorator. For example, if I get rid of that decorator and run this, it prints one line. If I put that decorator back and rerun this, it prints 3 lines. I want you to go ahead and give this a shot. It's not too often you're going to actually create your own decorators. You're more or less going to be using them. But in the possibility that you get into like open source or really advanced Python, then you're going to be creating your own decorators. And it's really important to know how these work and the order that things happen. For example, we have something happening before our function, after our function. Go ahead and try that out, and when you're ready, let's head on over to our next lesson. Welcome back. Let's talk about generators. So a generator is this really, really interesting concept. So for example, if you have a list, so LST is equal to 1, 2, 3. 1, 2, and 3 are going to be stored in memory at all time. Now let's say this list has 10 million numbers in it, which if you're getting into data science, it could have 10 million numbers in it. And you don't want to store all of that in memory because then you have to crank up the RAM on your computer, and your computer is going to need to, well, basically your computer is going to get really expensive if you just throw hardware at it. A generator is a software way of saying, do something with the first number, then do something with the second number, then do something with a third number, and it doesn't care what came before or after it. Now, a generator is typically put into some sort of function. So we could say def myfunc for some sort of number in a range. Range is already a generator in Python 3. So 14, for example. Print num. And when we execute myfunc, Python lesson 12, that's not going to do anything because it's in the function. Let's try that one more. There we go. It says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, not bad. You know, we're only working with 14 numbers. This is not technically a generator. But let's say we wanted to do something big, like make this always return all these numbers to the exponent of itself. So we would do num to the exponent of num. So for example, 10 to the power of 10, 13 to the power of 13. And instead of return, which is only going to execute once, like let's try this out. That's not going to work. Let's do total is equal to myfunc and then print the total. Shows up with just one number. What if we wanted multiple numbers? What if we're working with really big numbers? Well, instead we could use the keyword called yield. And what yield is going to do is it's going to say, this function is now no longer just a function, it's a generator. It's going to loop through every number from 0 to 13, and it's going to yield whatever that number is to the exponent of itself. Now let's go ahead and print this. And we see when we print myfunc, it is a generator. Now again, remember, a generator is only going to work one number at a time. So in our first example, where it was just a list, it knows about number 0 through 13. And in a technical way, we can access those numbers. But if we're working with really big numbers, we don't want that. Or if we're working with really big data sets, we want to use a generator, so it's only dealing with the task at hand. It's not dealing with anything that came before or is coming after it. And so the idea here is you're now writing code that's memory performant. So if it's doing 14 to the power of 14, it doesn't care about 13 to the power of 13. It doesn't care about 12 to the power of 12. It's simply going to do this once. And when you try to access that number, then it's going to do the math. So it's kind of lazy. It's going to do the math only when it's demanded. It's not going to do it right off the bat. It's not going to try to store all of this in memory. The only thing it's going to do is store 14 to the power of 14 in memory. And then when it moves on to the next number, it's going to do 15 to the power of 15 and totally forget about 14. Now in typical Python, let's say you're doing Python for web. You're not going to see yield a lot, but in data science, you're going to see it a lot. And it's very important that we know how this works. Let's go ahead and rename this from myfunc to myGenerator. And let's get rid of this. And now we can say for num. Let's not use num. Let's say big num in myGenerator. And we saw down here that this was a generator object. We can loop through these numbers and we can print them out. Print big num. And let's go ahead and execute this. Now, this is so fast with Python, we're not even going to notice what's going on. But what it was doing was first iteration, then the second iteration, then the third iteration, then the fourth, fifth, all the way down to the very last iteration. And you notice how these numbers are getting pretty big? It doesn't actually care what came before it or after it. And what's important about this is we can deal with really, really big numbers. So let's do really big number like 50 to the power of 50, and let's see if this possibly crashes my computer. Look at that. It was able to do all of that quite easily. So I guess I was worried about it crashing my computer for no reason, but it was able to do all of this logic quite easily. And so the idea is, when it got up to 49, it only worked on 49. It didn't have to remember what 48, 47, or 46 were. It didn't have to care about what's coming next. It simply said when it was on 49, work on 49 to the power of 49. Gives us this massive number here. And none of this needs to be stored in memory. Whereas if we had a list, we would have to have all of these numbers stored in memory. Now, numbers are small to store in memory, so it's not really that big of a deal. But when you're dealing with giant data sets, especially in things like machine learning or data science, you're going to want to use yield to make sure that your computer doesn't run out of, well, basically thinking power. It's not going to run out of RAM. Now, if you ever wanted access to these, let's say we said, let's just comment that out. And let's say we wanted to get all of these numbers. So all numbers is equal to my generator. And then we wanted to print these numbers for whatever reason. All numbers. Let's go ahead and execute this one more time. And it doesn't give us anything. It doesn't give us these numbers. Instead, it returns a generator object. Now, if we wanted access to these numbers, what we could do is cast whatever this generator is going to return, the whole thing, all of these numbers, we could put that into a list. Let's go ahead and execute this once it's being cast as a list, and we see all these giant numbers in here. Now, at this point in time, when we're casting this as a list, this generator, whatever it returns, all of these numbers is what it's going to return, is going to be stored in this variable called all numbers. So now we're actually saving this for later. Whereas with just a regular generator, our previous example, we're not saving these numbers for later. We're just doing something with these numbers one at a time. But with a list, we said, yeah, okay, process all of these one at a time, and then all the saved values from that yield keyword goes into this list. And that list is going to be stored in memory, so we can work with this list down the road. Now, why we would do this, or where we would do this, is if we're working with big numbers or a lot of processing, it can do a lot of processing one task at a time. It doesn't have to worry about all the other stuff before or after it. And then we can put just the answer into a list. So while the computer is doing 37 to the power of 37, we don't care about that processing. So basically we're saying this is a little more, what's the word I'm looking for here? Temporary. It's a little more temporary. And so, or disposable, that's a better word. It's going to do one thing, and then when it's done, it's going to throw it into that yield keyword. If it moves on to the next one, it's going to dispose of this in memory. It doesn't really care what the last one was. It just cares about the current task at hand. Whereas with a list or any other data type, once we store it in a variable, it's actually being stored in that variable. So to use a generator and then store it into a variable, not really the proper way of using a decorator, not a decorator, but a generator. This is more or less what we're going to use. So really it's a way to do some sort of processing and then throw it away. So we're going to say for every big number in my generator, print it out. And it's going to process 1 to the power of 1, 2 to the power of 2, 3 to the power of 3, all the way up to 50 to the power of 50. And it's going to print out one at a time. It's not going to store all of it in memory. It's just simply going to do one thing at a time. So it's really, really good for disposable code on large data sets. Now, again, if you're getting into web development, you're not going to see generators all that often, to be honest. But if you're getting into data science or machine learning, you're going to see this all over the place. It's a very, very important concept in Python programming. And in fact, we can do one more example here. Let's check out range. So we can say total is equal to range of 50 and print total. And we're going to see that this returns a decorator as well. And actually, it didn't return a decorator. It returned the function range 0 to 50. It is a generator behind the scenes though, and what we don't see is that it's not looping through and creating a list of 1 through 50. What if we did list range 50? We now get a list from 0 to 49, or 50 numbers in total. And so it works the same way as our made-up generator does. Now, one thing to keep in mind is once you iterate on one of the generators in here, it's not going to work anymore for you. So let's go ahead and uncomment this. Let's get rid of this example down here, and let's rerun the script. And it should print all numbers, but then print is not going to work at all because there's not going to be anything in there. The generator has exhausted itself. It's a one and done kind of thing. And actually, I'm just looking at this code and it's not going to, because it's going to create a new generator for every one of these. Let's go ahead and throw this into a variable. So my var generator is equal to my generator. And let's swap this out here for my var gen. And we can see that it prints all of these numbers, but it's not doing anything in here. So this generator, this function, we threw this into a variable. We then said, hey, execute this. So it said 1 to the power 1, 2 to the power 2, 3 to the power 3, 49 to the power 49, all the way through all those numbers, stored it in a variable. That generator then exhausted itself. So if we try to access that generator again, we're going to see that it doesn't print anything. And all it did was print our giant list here, but it didn't print out one at a time. Kind of like that pyramid shape that we saw right up here. It's not going to print any of those because that generator is done. It's a one and done thing. So if we wanted to access that generator again, we have to, in a strangely worded way, access that generator again. And so we do it this way. We said call it once up here, and then call it again down here, and this time we're going to see different result. We're going to see all these large numbers, and above it we're going to see this list of numbers. And so one thing to keep in mind with a generator, it's a one and done thing. Once you exhaust that generator, it's done. You have to create a new one. Or not create a new one, that's bad wording, but you have to instantiate or generate a new generator. Once you've created that new generator, then you can do whatever you want with it. But if you try to execute that generator more than once, if it's like, for example, stored in a variable, it's going to be exhausted that first time. It only cares about performing once. It's not like a function. A function you can keep using over and over and over again. A generator is a one and done type thing. All right, let's talk about pipenvs. Pip environments. I'm saying pipenv. And in Python 101 or Python 201, I can't remember, we used a Python command called python-m venv.venv, and then we got inside of a virtual environment, and this created a virtual environment for us. There's another way to do this. There's actually several different ways to create a virtual environment, but another common way is a pipenv. And I personally really like pipenvs because they're nice and simple. And so we're going to do this one in our command line here. Let's make that bigger. Let's get rid of this sidebar here. And so I'm in my Python 301 folder. And first of all, what I want to do is pip install pipenv. And it's going to collect pipenv. And ta-da, I have pipenv. Now what I can do is type pipenv, and it gives me a list of commands. Check, clean, graph, install, lock, open, run, script, shell, sync, uninstall, and update. This is a lot easier than writing python-m venv.venv. Instead, what we can do is type, and I'll clear this off, we can type pipenv install, and this is going to create a pip environment for us. So let's just do pipenv install. Does a thing. And it says to activate your project's virtual env, run pipenv shell. Pipenv shell. And now we are inside of a pip environment. You can see that I'm inside one because it has brackets over here. Let's go ahead and type python-v, and we're going to see that I'm using Python 3.9.0. Cool. That's nice. Let's get out of this by hitting Control D. So CTR plus D. Cancel with Control C, Control D. That exits our pipenv. Now if I want to go back in, I do pipenv shell, and I'm inside of it. Then I can do pip install. Let's say I wanted to install Django is equal to 2 point something. Just let it install. It's getting 2.2.17. Pip show Django. And I have 2.2.17. Now I know on my computer I don't have that version. I have Django 3.1 point something or other. And so this is now completely isolated from the rest of my computer. And you can actually see location of where this is being used. It's in my users folder, calebtallien.local, share, virtual ems, Python 301, that's the folder name, then some sort of hash, lib, Python 3.9 site packages. Cool, let's get out of here with Control D. And let's say we want to get rid of this pip environment. We can do pipenv --rm. And just like that, done. We don't have a pip environment any longer. And so this is a really good way to create an environment and to delete an environment. Now, let's say you have a project using a certain version of Python. There's two different ways to use Python. when it comes to versioning. You can use pyenv, and you can switch your Python version, or the way I prefer to do it is with pipenv. And I can do pipenv install -- Python, and let's do Python 3.7. In our last version, our last pipenv, we used Python 3.9. And so let's go ahead and use Python 3.7. Pipenv shell. Let's just clear this. Python -v, and I'm using Python 3.7.2. So there's two ways to use multiple versions of Python. I personally prefer this way because when I'm done with it, I can simply say pipenv -- rm, and that's just going to remove it. Boom, I don't have a pip environment any longer. Now if we did ls-la grep the word pip, we're going to see we have two pip files. Now this command is actually going to be a little bit different if you're on Windows. It's probably just dir. You might be able to use grep. You can always just list out everything that's in your folder too. You can do dir if you're on Windows, or ls-la if you're on Mac or Linux. And I've got a pip file and a pipfile.lock. And what this is, the pipfile.lock and the pip file specifies what kind of packages are involved inside of this pip file. Now, I showed you when I do pip install Django that it gave me Django 2.2.17. The proper way to do this would be pipenv install. Let's just create a new pipenv. And let's clear that. Then we can do pipenv install Django is equal to 3.1. And it's installing. Now, the one downside to pipenv is when you are installing things, it takes a couple seconds longer. Now, in my opinion, it's just a couple of seconds for a nice virtual environment. Life is easier this way. Pip is faster than pipenv. Some people have a problem with that, some people do not. Let's do pipenv shell. Clear. Pip show Django. And now we have Django 3.1 in here. And we did that from outside of our virtual environment by writing pipenv install, and then the package name is equal to the version. And again, the really lovely thing about this is we can do pipenv -- rm, and it's going to clean up our pipenv for us. This whole folder is going to be deleted, so we're not wasting space on our computer. Now, if you're like me and you're running on a Mac, you might not have that much space, and you might want to delete your virtual environments when you're done with them, if they're just like throwaway virtual environments. I do that all the time. Now, I personally love pipenv. I like it more than a Python -n venv.venv. Venv. It's just a lot to type. It's kind of weird typing too, just because this is going to use the Python version that's on your computer. Now, if I wanted a different Python version in a virtual environment, I could do pipenv install -- Python, and then the version of Python I want. And that's going to work for me. Now, the other way of doing this, using different Python versions, is using pyenv, which is a great way to use different versions on your machine as well. But I like to localize my project so that everything is inside of a virtual environment, because what works on Python 3.4 is not going to work necessarily on 3.9. And if I have a project using Python 3.9, but my computer only has Python 3.8, oh, now I can go ahead and use pipenv install -- Python 3.9 and get that up and running. Now, as a little caveat, you might need pyenv installed. If you need pyenv, you can go and look at how to install pyenv on your computer. It's going to be a little bit different depending on your operating system, but I'm going to leave that in your hands because you are now an advanced Python developer. Essentially what I'm saying is you have the skills to figure this out on your own. And the whole lesson really is there's multiple ways to do multiple virtual environments. We could do pipenv, we could do Python -m venv, we can use virtualenv, we can use Docker, we can use Vagrant, we can use all sorts of different layers of abstraction. I personally like pipenv. Now, there's no task, I just wanted to show you this. I just wanted to show you that this is an available option for you. Moving forward in our next, it's not even a lesson, it's our final project. we are going to be creating a banking app using classes. Alrighty, welcome back. Let's go ahead and create a final project. Now in this project, what I want you to create is a banking app. And it doesn't need to be super complex, but it does need to have a few little extras in it. So first of all, this should be class-based. It should have methods in it for withdrawal and deposit. And after every withdrawal and every deposit, I want you to write the transaction to a Python file. Now, we didn't cover how to open and write to files in Python 3.01. That was a Python 2.01 thing, if I believe correctly. So what I want you to do is I want you to try creating a project that's going to ask the user over and over and over again what they want to do. Do they want to withdraw or do they want to deposit? And how much do they want to do? Then I want you to keep track of all of that inside of a class called bank. After every transaction, write that transaction to a Python file so we have a history of that transaction. Or not just that transaction, but all transactions. Now, I'm not going to give you any more clues other than we're going to be using while true, we're going to be using input, we're going to be using classes, methods, and properties. This should make your brain sweat. This is hopefully all brand new stuff to you. Well, classes, methods, and properties should be brand new to you. Input, you should know. While true, you should know. Oh, what else do you need? You need to know open syntax for managing files. You should already know that one too. If you don't, definitely go and research how to create this. Now, what I want you to do is try this on your own. Don't watch the rest of this video. I'm going to show you how I do it. I've never built one of these, by the way, so you're going to see all the errors that I maybe make as well. But if anything here is new to you, you don't know how to do it, you can't remember, I'm going to ask you to not refer to another video. Try the best you can, and if you get really, really stuck, go to Google, go to Stack Overflow, and look for your answer on there. Because 50% of coding is solving problems, and you need to learn how to solve problems on your own. If teachers always hold your hand, honestly, you're not going to learn. And I want you, as my student, to actually learn. Not just watch this because it's like a tutorial style Netflix, you know? I want you to actually be able to create a Python app, and then, you know, maybe one day we can actually work together. How cool would that be? So go ahead and create a banking app from scratch. Remember, it's going to have to ask the user for a withdrawal and an amount, or a deposit and an amount. Keep track of all of that. What I'm going to do is fade this out and fade back in, and I'm going to show you my solution. All right, so first of all, I'm going to call this project.py, and I'm going to select all of that, comment that out, and use that as a guideline for what I have to do. So the first thing I need is some sort of banking app. I need to create a class called bank. And what is my initial amount going to be? Well, I'm going to do def init self, and the initial amount is going to be 0. That's how much I'm going to open this account with, $0. And let's use a float here, 0.00. Self.balance is equal to initial amount. Then I need to withdraw and I need to deposit. So def withdrawal self amount. I'm going to take that balance, self.balance, and let's move this up. Self.balance is equal to self.balance minus the amount. Now, what if this amount is, let's say, a string for some reason? We could say the amount is equal to float amount. Now, we don't actually know if this is going to work or not. So what we can do here is, oops, what am I doing here? Try to cast that as the amount. Accept a value error, and that amount is going to be 0. And then we're going to set that new balance. We also want to do deposit. Def deposit, how much? It always takes self. It's going to take an amount. we want to do the same try and except here. Try amount is equal to float amount accept a value error if it cannot cast that amount to a float. And let's change that amount to 0. Self.balance is going to be the self.balance plus whatever that amount is going to be. So either we're adding to our account or we're adding nothing to our account. And when we withdraw, we're either taking away from that account or we're taking nothing away from that account. Let's make this one step smaller here so we can kind of see this in one view. And now let's go ahead and instantiate this. Let's do account is equal to bank. What does it take in its initial amount? Let's say I'm going to open this account with $50 in it. 50.00. No, 50.50. Let's do that. Then I can do account.deposit. And let's say I want to deposit $10, or yeah, $10 in there. And then let's print out my total amount. Account.balance. And then let's say I want to withdraw $14.75. Not with a comma, but with a decimal. And let's print out that account balance again. Let's make sure we spell that right. Thank you, VS Code, for showing me a typo there. And let's open up our terminal and run this. And so we started off with 50.50, we added 10, so we got 60.5, that's good. And then we took out 14.75. So 60.5 minus 14.75 is 45.75, so that seems right. I'm not going to check that math, I'm pretty sure the computer knows what it's doing. And now we need to add transaction log, and what else do we need to add in here? Oh, we need to ask the user for input. So I'm going to make this one step smaller. I accidentally hit the wrong button there. One step smaller. And let's do another method in here, def log transaction self, and then some sort of string. What are we transacting? What are we doing here? And let's just call this transaction string. Now we need to open a file, so we can say with, that's using a context manager here. We can say with open transactions.txt. We're going to append to it all the time or create a new file if it doesn't exist. As file. Then we can say file.write. What do we want to write? We want to write the transaction string. And let's maybe always append a new line at the end. So let's use an F statement here. Not an F statement, an F string. And throw a new line in here. And that comes from Python 201, where we learned how to deal with files. So now after every withdrawal, we can simply say, if there is an amount, remember, if zero is, or if the amount is 0, this is going to be false. So this is not going to execute. So we can say if amount, then do a thing, self.log, log transaction, and this takes an amount, or not an amount, but a string. It takes the transaction string. So let's call this withdrew how many dollars? The amount. Let's do the same thing with deposit here, and what I can actually do is copy that. And we just have to make sure that we swap out this. Always be careful when you copy and paste. So we're going to say the balance is equal to the balance plus whatever amount whenever we deposit. Log that transaction. We didn't withdraw. We deposited the deposited the amount. And let's go ahead and open up our files here on the side. And we don't see transactions.txt. Is that what we called it? Transactions.txt. We don't see that in there yet. Let's go ahead and save this and run this, and let's see if there's any typos or anything. And okay, cool. And it deposited amount. I did something very wrong there. What are we doing here? First of all, that's an F string. This isn't JavaScript. That's an F string. This isn't JavaScript. Let's go ahead and run this again. We see transactions. Oh, look at that. Deposited $10, withdrew $14.75. Let's also add the balance in here with a new balance of self.balance. And if I make that just a weensy bit smaller here, we can see that A, I have a typo, and B, that I'm using an F string. And in fact, we could get fancier with this. We could say something happened, and instead of a new balance, we could do tab, tab, tab. Balance is whatever that self.balance is. Let's go ahead and clear out transactions.txt, and let's run this once more. Check transactions.txt. Deposited $10, new balance 60.5. Withdrew $14.75. New balance is $45.75. Okay, this is looking pretty good. Now we need to create a loop of some kind to ask the user for input over and over and over again. Let's close that down. And we have all of our logic working, so let's go ahead and wrap this in something called a while loop. While true, do a thing. What do we want it to do? We want to ask for an action, is going to be input. What kind of action do you want to take? Then we can say, if action is in a list of withdrawal or a depositor, I don't know why I wrote that, then do a thing. So then we can say, if action is equal to withdrawal, amount is going to be, what kind of amount do we want? Input. How much do you want to take out? And then we can do account.withdrawal the amount. And I'm not worrying about typecasting here because we're doing it in here. Nope, not there. In here and in here. Then we can say else, because the action is either going to be withdrawal or deposit. If that's going to be a deposit, how much do you want to, let's say, not take out, but put in? And account.withdrawal is going to be account.deposit. Deposit the amount. And then down here we can say print your balance is account.balance. Now, we need to instantiate this before we get into the while loop so that we're not creating a new account every single time we iterate through the while loop. And let's get rid of that, and that, and that, and that. And so now we have an account object, and we're going to either withdraw or deposit and then print out the balance. Let's see how this turns out. What kind of action do you want to take? Let's say I want to deposit. How much do I want to put in? Let's say I want to put in $13. My balance is now $63.50. That's correct. What kind of action do I want to take? What if I want to withdraw? How much do you want to take out? Let's say 13.50, so that gives us an even 50. And let's quit with Control C. Oh no, we get a keyboard interrupt error. And that comes from this action line. Let's try this. Try, except, and what was that called? That was called a keyboard interrupt error. Nope, it was just called keyboard interrupt. Let's copy that. There we go. And we're simply going to break out of this loop. Let's go ahead and try this out. What kind of action do I want to take? Let's cancel. It simply canceled for us. We could even say print leaving the ATM. And let's put that on a new line. And put that on a new line. Let's quit. It says leaving the ATM, and I gracefully left using a keyboard interrupt exception. Cool, this is coming together quite nicely. Now, one last thing we need to consider is what if the action is not withdrawal or deposit? Let's do this. What kind of action do I want to take? Say I want to rob the bank. It's not going to do anything. This is a bad user experience. It just keeps asking. which I guess is not the worst user experience, but it's not a good user experience. So we can zip this up or collapse it, and we can say, else, if the action is not withdrawal or deposit, what do we want to do? Print. That is not a valid action. Try again. Now let's do this. Let's say we want to rob. Not a valid action, try again. Rob it. Okay, what if we want to withdraw? It's a hard word to type. Withdraw without a space at the end. How much do I want to take out? Let's say I want to take out $900. My balance currently is minus $849.50. So now I'm getting into overdraft, and if you wanted to, you could extend this to overdraft and loans and, all sorts of things. But that is essentially the entire project in a nutshell. And when I cancel, it gracefully cancels. It doesn't just error out. It says I'm leaving the ATM. So let's recap what this looks like. We have a class called bank. When you open up an account, how much are we putting in there? By default, $0. I put in $50.50 to begin with. Every time there's a transaction, we're going to open up the transactions.txt file. Let's go take a look at that. And it's showing me everything in here. That's great. That's doing exactly what I want it to do. For every transaction, whether it's a withdrawal or a deposit, we're going to take that file, we're going to write to it, whatever that transaction string is. So withdrew or deposit the amount, tab, 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 balance with the balance in there. Cool, simple transaction logger. Then we've got a withdrawal method. We're going to try to cast this as a float. If we cannot cast this as a float, it's going to say the amount is 0. And if the amount is greater than 0, basically as long as it's not 0, we can take some sort of action. We're going to automatically change that balance from whatever it currently was. So I opened up with 50.50, and it's going to minus the amount that comes in here. And then we're going to log that amount and that withdrawal. Lastly, we have deposit. Same thing, we're going to try to cast this amount as a float so that we can do numerical math on it. If we can't, it's going to say that amount is 0. If that number is in fact a proper number, if that amount is a proper number, we can then change that balance to be balance is equal to balance plus whatever amount, and then we said in our transaction logger, deposited the amount. Lastly, we created a new account, and then we said, walk up to the ATM. Essentially, that's what this is saying here. While something is true, just keep asking. Keep asking and asking and asking. Action, what kind of action do you want to take? If we said Control-C, if we canceled, we get a keyboard interrupt error, and we're simply going to leave. We're going to break out of this loop. Otherwise, if the action is in withdrawal or deposit, take action here. And if that action is withdrawal, we can say, how much do you want to take out? And then withdraw that amount. Otherwise, if it's not withdrawal, we know it's going to be one of these two. It's withdrawal or deposit. We know that this is withdrawal. So by logic of reduction, this has to be deposit. Then we say the amount is going to be input. How much do you want to put in? Account.deposit the amount, which is going to work all of its banking internals. And then we can print out our balance, account.balance. Otherwise, if someone is like trying to rob the bank or do something else with the bank that they really shouldn't be doing, we're going to print that is not a valid action. Try again. It's going to then execute that loop one more time and go over and over and over again until you leave the ATM. And that's really all there is to this particular project. And we're making use of a lot of different things we learned in Python 301. We're not necessarily using everything. We're not using a generator. We're not using a decorator, although if you wanted to, you could figure out a way to add those in there. And if you wanted to, you could probably turn log transaction into some sort of decorator to decorate withdrawal and deposit with, so that we don't have to explicitly write it in here. That would be pretty cool if you could do that. And what else do we talk about? Pipenv, we probably should have done this in a pip environment, but you know what? We're not installing any packages, so we didn't need a pip environment for that. We just needed regular Python on our computers. And we didn't use a generator because we didn't actually need to use a generator. A generator would be really good if we were looping through like 1 million different customers in our bank, and we needed to figure out which customer to find. So that's all there is to this particular banking app. If you didn't give this a try and you just watched right through this video, please go ahead and try this out now. This is really, really important because it's great practice using a class. Don't forget, if you have questions, you can always join the Learning to Code group on Facebook. We're happy to answer any Python question that you have in there.